Okay, problem number 55, referring to a lighthouse that's 2 kilometers from point P as shown in the diagram. They're saying the light makes a rotation of 1 revolution per minute, and they want to know how fast in kilometers per minute the beam of light is moving along the shoreline when it's 1 kilometer from point P horizontally as shown in the diagram. Well, it's nice that they provided a diagram for us. That's a good starting point. We're going to add some things to the diagram. First of all, let's look at this 2 kilometers. That represents the distance of the lighthouse from point P. That's going to remain constant. The lighthouse is not moving. This 1 kilometer on the bottom, that's representing a point in time, but actually the beam of light is moving along the shoreline, so that distance on the bottom is going to be varying. We're going to call that x. And now let's call this angle up top theta, because that's the angle that's going to be moving as this beam of light rotates. So now let's set up some rates that are provided, and the rate that we're looking for. We can tell that if the beam of light goes in 1 full circle, 1 revolution per minute, we can tell then that d theta dt is 2 pi kilometers per minute, because 2 pi represents 1 full circle. Now they want to know, well, what's dx dt when x equals 1? Okay, we'll set up an equation now. Let's see here. We've got an angle theta. We have an opposite leg and an adjacent leg, so it's SOHCAHTOA. That'll tell us that the tangent of theta is going to be x over 2. Okay. Let's differentiate this thing. The derivative of tangent is secant squared. The derivative of theta with respect to t is d theta dt. Now remember, x over 2, same thing as saying 1/2 x. So the derivative of x over 2 with the derivative of 1/2 x is just going to be 1/2. And the derivative of x with respect to t is dx dt. Now we'll substitute and solve. Let's see here. Secant squared, we're going to calculate what that is. Secant squared. D theta dt, we know this is 2 pi. It's going to equal 1/2 dx dt. All right. So remember, what we're looking for here is, what's the secant squared of theta? So we need to find secant of theta. Remember that secant is the reciprocal of cosine. Okay. Now, looking back at our diagram, cosine is SOHCAHTOA. Cosine is adjacent over hypotenuse. So let's take a look right here at our diagram. Cosine of theta is the adjacent leg over the hypotenuse. The adjacent leg to theta is 2. Let's find the hypotenuse when x is 1. Remember the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. So 2 squared, 4 plus 1 is h squared. 5 equals h squared. So h is root 5. Side is root 5 when x is 1. So cosine is adjacent over hypotenuse, 2 over root 5. Okay. Now, let's take this and remember that secant is reciprocal of cosine. So 1 over 2 over root 5 divided by a fraction is the same as multiplying by its reciprocal. 1 times root 5 over 2. Secant of theta is root 5 over 2. Okay. Now we can get to work. Root 5 squared is 5. Root 2 squared is 4. So bringing this work over here, we're going to get 5/4 times 2 pi equals 1/2 dx dt. Okay, we're almost done. Multiply both sides by 2, and we get 2 times 5/4 times 2 pi equals dx dt. Okay, let's see what's going on here. 2 times 5/4 is 10/4 times 2 Pi is 24ths, so we can just clean that up and call it 5 pi. In kilometers per minute equals dx dt. 1x is 1. 5 pi. 5 pi matches option letter D. This problem is a great review of many skills, all in one problem. Hey, thanks for watching, guys. Keep working hard, hang in there. Stuff is going to get better and better and better the more we practice, the more we check, the more we correct.